Hi, today is SES and the Future of Content Delivery. My name is G. Ramos Carr. I'm a Senior Account Director at SES Government Solutions.
Jason Aurora, Solutions Architect here with the Aerospace and Satellite Group at AWS.
We're going to go over a few different things. So we're going to talk about the history of SES Government Solutions, the different assets and fleets that we have available, the innovation we've done with that fleet over the years, the benefits of an AWS Direct Connect, as well as the AWS Direct Connect partnership that we have, and then the architectures that enable our SES Cloud Direct solution. And then finally, how you can work with SES Government Solutions. SESGS, or SES Government Solutions, is a longtime provider to the federal government. We provide the backbone of communication, commercial satellite communications, or ComSatcom, to many of the services that comprise the Department of Defense. Trojans are a premier and longest running managed service being provided to INSCOM, or the United States Army and Information Security Command. This network allows their team to access the tool sets they train on no matter where they are in the world. To continue to support the US government, DoD, or federal civilian mission partners, SES Government Solutions is constantly updating and innovating our security posture to meet and exceed the requirements of the US federal government information assurance standards. Over our long history of supporting the US government, SES has innovated the fleet by designing and developing high throughput satellites in our GEO fleet, building a constellation of high throughput, low latency satellites in MEO, and then innovating that MEO fleet with mPOWER. SES owns and operates a fleet of over 50 geosynchronous Earth orbit satellites, or GEO assets, and our MEO fleet is comprised of 20 satellites in medium Earth orbit, which is also known as O3b, originally built to support connectivity to the other 3 billion that lacked proper connection to the internet. Come to find out, those capabilities enabled by such a breakthrough technology was valuable to oil and gas, mining, telecommunications companies, and government end users. With the success of our initial constellation, we've been able to innovate with O3b mPOWER. SES has funded 11 additional MEO satellites, and we'll have O3b mPOWER online in 2022. And our fleet of GEO assets provide global connectivity to end users with large wide beam options, as the GEO satellite can see a full third of the Earth from its orbital location in space. That capability enables video distribution, low demand web browsing, while providing global solutions with as few as 3 satellites in orbit. GEO innovation to HTS, or high throughput satellites, led to more capacity on each satellite through frequency reuse, going from hundreds of megahertz to gigahertz of capacity on a satellite payload. With the deployment and development of our MEO constellation, it enabled the connection of 600 forward and 600 megabits return on a single terminal, no matter where you were within 50 north and 50 south of the equator. As the MEO fleet is only about 8,000 kilometers in space, it is able to provide a MEF 2.0 certified low latency connection, and that allows for easy integration into existing network architectures, as it's a standard Ethernet interface. Our MEO assets enable completely new capabilities, including the most important today, cloud. Our GEO connectivity provides access to proven technology and mature solutions. Our GEO assets offer access in multiple frequency bands. Globally, we offer C and KU band. We also have multiple satellites offering commercial Ka band connectivity. And then in specific areas of operation, such as AFRICOM, CENTCOM, and EUCOM, we can offer government frequencies such as X band or military Ka band on our GovSat-1 satellite. The main advantage of a GEO solution is that it enables the use of the most simple and cost-effective terminals. Our innovative MEO constellation provides an unmatched capability when it comes to the amount of throughput and the reduced latency of less than 150 milliseconds, which is similar to fiber-like connectivity, with a significant lower implementation time and the flexibility to move and relocate as your forces or your mission partners need. To enable a MEO connection, additional control plane scheduling and hardware components are leveraged to complete that connectivity. The complexity of a MEO connection also provides inherent security, complicating the enemy's targeting calculus. This also includes IPsec, CNSSP12 for command and control, and other ODNI level security features. The smaller beam size of 700 kilometers currently and 250 on mPOWER will provide the ability for mission partners to physically deter an adversary because of the proximity they have to be to intercept or interfere. The data required to track the ascending and descending satellites as well will require more capable hardware for an adversary to figure out how to intercept and detect and or interfere with our traffic. And similar to how AWS handles security of the cloud, we handle security of the satellite link where you handle security inside that satellite link. When you move to a multi-orbit solution, SES-GS is able to offer unprecedented resiliency and support the DoD's fighting SATCOM strategy. This multi-orbit capability fits in with government initiatives like DUSI that are clearly looking for that GEO, MEO, and LEO connectivity. Orchestration of data connectivity between the different orbits offers additional security options, whether that be multipath communications, providing security through diversification of which path you take. It also fulfills the PACE requirements, so your primary, alternate, or contingency and emergency solutions for communications for a warfighter. As you may already know, AWS Direct Connect is a capability offered to AWS cloud customers for optimizing end-user cloud connectivity. This allows for flexible, secure access to pre-established set of AWS peering points, which is especially important for US government customers. The connections bypass public internet, providing improved and more predictable application performance, and is available in a range of speeds, especially when you decide whether you're going GEO or MEO. It can also be managed, also be a managed connection backed by SLAs to assure workload connections and therefore application performance meet the needs of the mission partners. Different use cases include Internet of Things, mission-critical applications, and edge compute. Leveraging the fleet of satellites that SES owns and operates extends availability of cloud services to virtually anywhere in the world. With the use of our MEO fleet, you can access anywhere between 50 north and 50 south to enable high throughput, low latency connectivity for mission partners. And then SES-GS currently provides a number of users with global networks that leverage transmission security on the satellite link itself. SES is the only satellite owner-operator that is a Direct Connect partner. This offering allows the government and commercial customers to integrate two proven technologies to best meet their needs. As our team has spent the time and effort to productize the solution, our customers and mission partners won't need to expend the resources to research, design solutions, just to enable or extend their cloud services to environments where there is limited or no connectivity. The link on this slide will give you a little more information and insight on the combined solutions and different use cases, so feel free to access that. Now I'll turn it over to Jason, who can walk through some of the different architectures enabled by our partnership and that have been developed to show how AWS's hybrid edge solutions work with SES Cloud Direct.
Thanks, G. So SES Cloud Direct and AWS Direct Connect bring users cloud connectivity to the satellite edge. Users of SES's satellite service connect their end user terminals and equipment through the network of SES satellites back to the SES ground station or teleport. For those of you new to the terminology, a teleport is a large site for uplinking and downlinking radio frequency or RF signals to and from satellites. As G stated earlier, the SES teleports are strategically located around the planet to provide full coverage and full global connectivity. So that RF traffic is uplinked, downlinked, and routed at the teleport by SES operations, who are also in charge of the ground segment or ground station hardware. From the teleport, that customer traffic is further routed to a co-location facility, which is a secure facility where SES establishes direct connectivity to the AWS cloud, isolated from internet traffic. With this, you can see how SES customers can connect their end user equipment to their AWS cloud environment. Now, as a Direct Connect partner, SES provides customers high availability links, establishing multiple connections at the co-location facility. Likewise, the RF chain is designed with high availability infrastructure as well. So the SES ground station has been architected to include hardware failover solutions for the ground system devices such as the frequency converters, amplifiers, modems, and other ground station equipment to remove any single points of failure. Additionally, multiple satellites are leveraged to provide high availability in the satellite or space segment, thereby creating the reliable SES Direct Connect satellite connection back to the cloud, enabling access to AWS services for both commercial and government users globally. So a number of AWS hybrid edge solutions can be used with this SES Cloud Direct solution, as G had mentioned earlier, such as the AWS Snowcone device or the AWS Snowball Edge devices to provide more ruggedized solutions at that remote edge, and I'll touch on that more shortly. Additionally, we have the AWS Outposts for extending the AWS cloud into the data center or teleport. So the AWS Outposts, you can run AWS services locally and connect to a broad range of services available in the local AWS region. AWS Outposts supports workloads and devices requiring low latency access to on-prem systems, local data processing, data residency, and application migration with local system interdependencies. Now, the low latency provided by the MEO constellation that SES has opens up further capabilities for pushing the outpost to the remote edge beyond the teleport. So those customers with the data residency requirements for keeping their information in the teleport can still leverage their cloud services using AWS Outposts. Additionally, integrating an outpost at the uplink facility can greatly reduce the latency on a link, which is especially important when leveraging a geo asset. Eventually, when combined with the mPOWER solution, where the latency will be further mitigated, this will allow mission partners to leverage as small as a 2-rack unit device to provide cloud services in a completely different security posture. As I spoke about earlier, we can add Snowball Edge devices or devices from the Snow family at the remote location to provide additional processing and storage at the edge. By processing large sets of collected data at the edge, such as UAV imagery or video footage, we're able to transmit back only the most critical information and analyses that we derive. In DDIL conditions, or denied, disrupted, intermittent, or limited bandwidth conditions, a Snowball Edge can be used to provide compute and processing for those workloads running in these austere environments. When those devices are connected by a satellite, those environments become connected, allowing for the workloads to be front-loaded, reducing their required bandwidth, so only the mission-critical information needs to be synchronized to the cloud. Now, to discuss some of the real-world applications of this architecture and using the Snowball Edge solution in tandem with the SES Cloud Direct, I'm going to hand it back to G to showcase the work that SES has accomplished with the AWS Disaster Response Team.
When supporting the AWS Disaster Response Team, we enabled the use of the Team Awareness Kit, or TAC, locally to synchronize data from there to the cloud using our AMC-21 satellite. AMC-21 is a 50-state coverage satellite that provides full coverage of the Caribbean all the way out to Hawaii. This allows for a common operating picture of personnel deployed at the disaster site to monitor the health and safety of staff, the TAC server, while allowing for leadership to coordinate and deconflict local resources from their command center. Since this data was also being fed into the cloud-based TAC server, which you can see here, the remote observer could even see the location and movement of personnel throughout the disaster, and even giving them the ability to apply analysis to the data without having to tie up valuable local resources. This capability can be leveraged for other technologies to provide differentiated solutions to different mission partners. In general, AWS provides a FedRAMP-approved cloud services to be utilized by U.S. government customers today and optimized for user cloud connectivity. SES-GS provides secure global access built to government standards for data transmission over commercial satellite communications links. This allows the departments and agencies within the government to leverage the heavy lifting that has been already completed by others to easily enable their mission sets. In this diagram, you can see the resiliency and highly available infrastructure that has been put in place to support a range of different U.S. government customers. Our connectivity and Cloud Direct solution enables a range of different capabilities to many different remote platforms and/or sensors. SES-GS has a few different ways that we can enable support for your mission needs. Our GSA multiple award schedule gives easy access to our capabilities. We also have a CS3 contract for complex commercial SATCOM solutions via the GSA. And then we also have ComSatCom subscription services under CSS 82, which is a MEO blanket purchase agreement for US government end users. AWS has multiple contract vehicles, as you can see here, that can be leveraged depending on the department or agency you work for.
So we encourage you to get engaged with our training and certification content today. As you build your skills, consider preparing for one of our 11 AWS certifications. These industry-recognized certifications span foundational, professional, and specialty levels to validate AWS knowledge and skills, building your credibility and confidence. Scan one or both of the QR codes on the screen to get started with your cloud skills, training, and certification.
Thanks for attending. Thanks for any questions you may have. We'll be here for additional Q&A.
So my question is, with all of your teleports located around the world and AWS's desire to extend the cloud, how do you see that infrastructure that you already support and AWS's desire to extend the cloud to the farthest outreach places? How do you see that work?
Yeah, I mean, I think there's a few different ways to leverage both of our already pre-existing infrastructure. You know, that first architecture allows a user with just a satellite requirement today or satellite hardware and capability to leverage everything we've done in the background to enable, you know, whatever Amazon service they want to connect to with little to no new investment of hardware or equipment. Then depending on workloads or security posture, I think bringing that workload out to the teleport really enables some different technologies or capabilities by reducing that latency to the cloud. And then obviously when you bring remote compute out to the edge, it gives you so many different options as far as now you've got resiliency in theater or locally where you can operate on a cloud, you know, using those local processes. And then when you do have connectivity, it's just even more enabled.
And then also, just to expand on that a little bit, as the SES Direct Connect partnership grows, and as we find more customers who are interested in cloud connecting their services using SES's satellite connectivity, I think we'll have more and more opportunities to create more direct connect circuits for SES and expanding the SES partnership across the globe. Thank you.
Any additional questions? All right, well, appreciate your time.